Welcome to part 2 of section 7.4, and today we're going to be discussing the factor theorem. Okay, yesterday when we were talking about the remainder theorem, we learned that instead of having to directly substitute a number into a polynomial, we could just use synthetic division and get the same result. Okay, today we're going to continue that idea, but now we're going to see that there is a special case when we get a special remainder. So the factor theorem states that x minus a, so this binomial, x minus a, is a factor. Do you guys remember what factors are? We did a lot of factoring in the past couple chapters, and that means writing things as products. Factors are things that you multiply together to get a product. So we're going to be looking for little pieces that we can all multiply together to get one big polynomial. Okay? So x minus a is a factor of the polynomial f of x if f of a equals 0. That says that if you use synthetic division, given that certain 0 and the remainder is 0 itself, then that is a factor of the polynomial given to you. Okay? So here we have this long, beautiful polynomial. Divide f of x equals x to the 4th plus x cubed minus 17x squared minus 20x plus 32 by x minus 4. Okay? If we have x minus 4, that means that our 0 is going to be what? If you guessed 4, you're correct. 4 is going here because if we set x minus 4 equal to 0, then x equals 4. And that number is what goes in here. Okay? Now we're going to take all of our coefficients, or fancy word for saying the number in front of all of these guys. Okay, we're starting with x to the 4th. The coefficient here is 1. Then we have to go to x cubed. X cubed, the coefficient is also 1. Then we have to go to x squared. X squared is negative 17. Then we have to go to x, which is negative 20. And then we have 32. If any of those were skipped, remember that we have to use zeros as fillers, or else we'll get the wrong answer. Okay? The first step is that we want to drop this first coefficient down. Whenever we're below the line, what do? We multiply. So we're below the line, so we multiply times here. 1 times 4 is 4. Then we add these two numbers. 1 plus 4 is 5. We're below the line, so we multiply. 5 times 4 is 20. Negative 17 plus 20 is 3. We're below the line, so we multiply. 3 times 4 is 12. Negative 20 plus 12 is negative 8. Below the line we multiply. Negative 8 times 4 is negative 32. Which 32 plus the negative 32 is 0. This means that x minus 4 is a factor of this guy. Ta-da! Because our remainder is 0. That is what this means. That this guy is 0. Okay? That being said, we need to figure out what is left over when this is a factor. Okay? So if we were going to write this guy right here, f of x, as a product. Yes, as a product. Okay, we know for certain that we have x minus 4. So if this is something, we know that we have successfully just pulled out an x minus 4, and that is a factor. So we want to figure out what else is being multiplied here. Okay? If that is the case, we work backwards going numbers here. So we're going to go from right to left and increase in degree. Okay, so this first one is going to be an x to the 0. And then this is an x to the 1, and then this is an x squared, and then this is an x cubed. Okay? So, that means that our leftover polynomial is 1x cubed, a positive 5x squared, a positive 3x to the 1st, which we just recognize that as x, and a negative 8x to the 0, which is just a negative 8. And this is our remaining polynomial after we divide out that factor from our original f of x. So this equals, if you were to multiply all this out and distribute this, basically undo whatever we did, you would get that guy. Okay, so we have just divided out this factor, and our remaining polynomial is this x cubed plus 5x squared plus 3x minus 8. Okay, so to get the remaining polynomial, you start, after you take your remainder, which is 0, you start with the next one. That's your constant, then your x squared, then your x cubed, and if it keeps going, you keep getting 1 degree higher every time. Okay? Alright. A couple examples, and we'll call it a day. Okay. We want to first show that x plus 3 is a factor of f of x equals x cubed plus 6x squared minus x minus 30. Then we want to find the remaining factors. This will be a great time. Okay. So if we have x plus 3 as a factor, that means what is going to go in my nifty little box over here? Yes. If you said negative 3, you're correct, because if we set this equal to 0, solve for x by subtracting 3 on both sides, we get negative 3. And who doesn't love negatives, right? Then we start here. We have our x cubed, our x squared, positive 6. Our x is a negative 1. And then we have our negative 30. Okay, if I want to show that x plus 3 is a factor of that polynomial, what am I expecting to get? That means that when I synthetically divide this, to show that it's a factor, the remainder needs to be 0. Okay? Alright, so the first step, I drop the first one. I'm below the line, I multiply. 1 times negative 3 is negative 3. 6 plus negative 3 is positive 3. 3 times negative 3 is negative 9. Negative 1 plus negative 9 is negative 10. Negative 10 times negative 3 is positive 30. And we get a 0. Ding, 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 ding. This is a factor. Check. We just showed that. Okay? So, that means that I know one of my factors is x plus 3. Okay? So we need to figure out, then we have to find the remaining factors. Okay, so what is our leftover polynomial? Remember, we start going right to left. We have our x to the 0, x1, x squared. That means I have 1x squared, which is x squared, a positive 3x to the first, which is just positive 3x, and a negative 10x to the 0, which is just negative 10. Okay, so now my job is to factor this guy. Yay! Who doesn't love factoring? Okay, so choices of factoring. We have quadratic formula. We have, oh goodness, what do we call it? Product sum. We have AC factoring if you want to do that. Yep, all good things. Or we can graph it, which I know none of you like to graph anyways. So this one, if I'm going to do product sum, what multiplies together to be negative 10 that adds to positive 3? If you said positive 5 and a negative 2, you are correct, which means that I get x plus 5, x minus 2. Okay? And then I have this guy left over. So this was my given one. Those two are the ones that I just found. This is our answer. So this is that polynomial written in factored form. Isn't it beautiful? Yes. I think it's lovely. So this equals f of x. Okay? Done. Alright. Next example. We want to factor this polynomial completely. 6x cubed plus 5x squared minus 3x minus 2, given that 3x minus 2 is a factor. Right? This is a little bit trickier because this has a coefficient. Process is still the same. What goes in here is the 0. So if I set 3x minus 2 equal to 0, I add 2 to both sides. So I get 3x equals 2, divide by 3. x equals 2/3. Okay, that means that this number is going to go inside here. So my 0 is 2/3. Okay? So process is still the same. We still set it equal to 0. Bam. Okay? Alright. Then we use our coefficients. So I have x cubed, x squared, x, and our constant. Okay, I'm already given that this is a factor, so the reason why we're doing this is because once we pull out that factor, then we can have a quadratic, which we know how to factor ourselves. So it's going to make the problem a little bit more understandable for us so that we can factor it in a way that we know how. Okay? So my first job is to drop this first one. 6 times 2/3. Okay? If we don't like fractions, you multiply by the top, divide by the bottom. So 6 times 2 is 12. Divided by 3, 12 divided by 3 is 4. And then I get to add. 5 plus 4 is 9. I'm below the line, I multiply. So I'm going to multiply by the top. 9 times 2 is 18. Divided by 3, 18 divided by 3 is 6. Negative 3 plus 6 is 3. 3 times 2 is 6. 6 divided by 3 is 2. Add those, I get 0. Yay! Okay, now the one big difference here is that we need to fix this because of this coefficient right here. Before I can rewrite my new polynomial, I have to divide all of these numbers by that coefficient. So I'm going to divide this by 3, this by 3, this by 3, which is going to give me a 2, a 3, and a 1. Okay? So right now I know that 3x minus 2 is a polynomial. Okay, here, this is my x to the 0, this is my x to the first, and this is my x squared. So I'm going to have a positive 2x squared plus a positive 3x plus a positive 1. Okay? So now I have to factor this guy. Coefficient of 2 in front, that means I get to do AC factoring. Woohoo! Get excited. Okay. So my A times C, my A is 2, my C is 1, which is 2. Okay. So what multiplies together to be 2, that adds to 3. 2 and 1. Alright, so that means that I'm going to be factoring 2x squared. I'm splitting up this 3 into a 2 and a 1. So I'm going to have plus 2x plus 1x plus 1. Okay? And then from here, I factor by grouping. So these two, I'm going to pull out a 2x and get x plus 1. This one, I just have a 1 to pull out. That's all I get. Okay? These both have x plus 1 in common. So I pull out that x plus 1. Can you see that? Pull out that x plus 1. And my leftovers are 2x plus 1. Okay? And those are the factors of the polynomial. Then you also have this guy from up here that was given. Okay? So this is our answer. Alright, that is the end of section 4.